All right, in lesson 11.5 for Algebra 1B, we are going to be learning to add and subtract fractions that have common denominators. So let's do just a quick recap of something that you obviously learned in elementary. So if I have 1/2 plus 3/2, or 3/2, I know that I can add these fractions together because they have these common denominators. So what I'm going to do is I only add their numerators. 1 plus 3 is 4, and whatever the common denominator is that they have, I keep. So it would be 4/2. Now, I'm not finished because can I reduce 4/2? Yes, it can be reduced down to 2. So we are going to add and subtract with like denominators, but we cannot forget we must reduce. And our reducing is going to be a little bit different because we're into factoring and everything. Okay? So first of all, I just double check. Everything in this lesson will have common denominators, but we just want to look. Yes, they're common denominators. So what I'm going to do is I'm going to keep it as 1. And then what I'm going to do is I'm going to pay attention to the sign they give me. If it's an addition problem, all I need to do is combine like terms. Well, we always want to write our variables first because that's standard form. So I find my x. Does x have anything to combine with? No, so I leave them x. But then I have 5 plus -5. Those are like terms. Well, what's 5 plus -5? 0. So here's my answer. But I look, can this be simplified? Can we cross out our x's here? Yes, we can. But when everything crosses out up top, what we are going to have left is a 1. So I have 1/2, or 1/2 is my final answer. Okay, let's do the same thing to the one on the bottom. I know I have common denominators, so I go ahead and write it, 5n. Does this n have any other like terms to add with? No, I just write it. The -3 plus 3, actually it's going to work out the exact same. -3 plus 3 is 0, so I don't write anything. And then I look, can this fraction be reduced? Yes, the n's can cancel out. When everything goes away up top, I'm left with a 1, 5 on the bottom. Here's my reduced answer. So let's do some more of these. Now we have a subtraction. Now subtraction is a little bit different than addition. This first step stays the same. Make sure I have common denominators. Whatever that common denominator is, I write it. But then this subtraction sign, just like remember when we were adding and subtracting polynomials back in chapter 10, when we saw a subtraction sign, what we did was we changed every sign behind the subtraction sign and made it an addition. If you do that, then you do not have to worry about, did I distribute the negative to everything? If so, this is going to make your answer much more easy to see. So now I look for the variable first. Does -x have any like terms to combine with? No, so I write -x. 4 plus -4, oh, it's going to happen again. 4 plus -4 is 0. Now, can I cross out these right here? No, the answer is no, I cannot. So this is my final answer, just like this. Because remember, this is part of a family. It cannot be touched unless it has the exact same thing. Okay, next problem. We have y plus 5 is our denominator. Because it's a subtraction, what I'm going to do is I'm going to go ahead and change all the signs, make it addition. So I actually have like terms. 3y minus 4y is -1y. -1 doesn't have anything to combine with, so I write -1. Now, is there anything I can do to cancel these out? Can I cancel out the y's? No, because this is part of a family and this is part of a family. If they're not identical, we cannot cancel them out. You say, wait a second, isn't there a GCF -1 in the top? Yeah, technically there is, but if you cancel that GCF out and you move it to the outside, is it going to change anything about your final answer? No. Okay, so we don't have to do the step if it's not necessary. Now we're getting into the bigger problems where we will need to simplify after subtracting. So I look, make sure I have common denominators, which I do, but anytime you see a 3-term problem like these, right here, go ahead and factor. So we're going to do our x, -1 goes at the top, -6 on the bottom, 1 times 6, 2 times 3, which one's subtract to give me 1, 2 and 3, 2 is going to be positive, 3 is going to be negative. So we have x plus 2, x minus 3. Is that our final answer? Nope. Now we divide the bottoms up. So now we have 3x plus 2 times x minus 1. So now we factored our denominator. So it's ready to be canceled out if there is another family that is identical to it. So we're going to subtract the top. But because it's a subtraction, I'm going to change both the signs, make it addition, combine like terms. 4x minus 1x is 3x. Plus 2, does plus 2 have anything to combine with? No. And this is a family, so if I want to, go ahead and put parentheses around it. Do you see any identical families in this problem? Yes. 3x plus 2, 3x plus 2. But everything went away on the top, so what does that mean I have left? A 1. X minus 1. Still a part of the family, so we can't cross out those ones. It doesn't work like that. And this is our final answer. So let's do the same thing for the next one. Oh, I see common denominators on the bottom, but it's definitely going to be a problem that needs to be factored. So -7 and 10, 1 times 10, 2 times 5. Which ones add to give me -7? -2, -5. So then I have x minus 2, x minus 5. And I'm going to bottoms up, divide. So the first one is going to simplify to x minus 1, and the second one goes bottoms up and 2x minus 5. So now we do have a subtraction problem, so I change everything behind the subtraction sign. -1x plus 3x is 2x. 1 minus 3 is -2. Now, what do you see about this numerator that can be done? It has a GCF. What is the GCF? 2. So what I'm going to do is I'm going to divide each of these by 2. Remember, where does that 2 go that we divide by? Right on the outside. X minus 1 over x minus 1 times 2x minus 5. Now, do you see any identical families? Yes. 2 over 2x minus 5. Now, can I cancel those 2's out? No, because this is part of a family, and we cannot cancel it out. So this is my final answer. So this is your homework for tonight, so if you want to go ahead and get started on that.